Okay, let's go ahead and look at the back side of our worksheet here. We have a couple of definitions at the top of the back page related to tangent circles, which would be any circles that are tangent to the same line at the same point of tangency. Notice that you can have externally tangent circles, which are two circles that only meet at that point of tangency, and then the internally tangent circles, which are sort of overlapping circles that all have the same point of tangency. So those two terms do come up a little bit, but we're not going to focus too much on them. We don't have any conjectures related specifically to them, but you should at least be familiar with those terms, externally tangent circles and internally tangent circles. Well, let's go down to the practice problems with tangents. And again, these are similar to maybe a couple of the problems that would come up in the homework. Unlike yesterday, we have only two. So in the first one, we're supposed to find W. Notice W is the arc here. So there's an arc measure that we're looking for that is W. We are given a couple of tangent lines or tangent segments. If we put a point at the point of tangency, then we'll have a couple of segments here. Just for the sake of explaining this, I'll call it A, B, and C or something like that. So basically we're looking for the arc between A and B. Now this 54 degrees that is at the vertex ABC, 54 degrees right here, that is not going to be the same as W. W is not 54 degrees. We think about what's happening here. On the front side, 6.2, we knew that tangent lines or tangent segments will be perpendicular to the radius drawn, the point of tangency. So even if you don't see the radius in the drawing, let's go ahead and mark a center point. And you're just going to have to do your best to kind of eyeball where the center is. So let's call that there. And then let's just freehand sketch a radius out to C and a radius out to A. Now we know from our investigation that these are going to be 90-degree angles. That was one of the conjectures on the front side. A tangent to a circle is perpendicular to the radius drawn to the point of tangency. Now since those are both 90-degree angles, I want you to be thinking about the fact that we really have a quadrilateral right here. And the quadrilateral goes something like from here, 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 and here. And you guys know maybe even what type of quadrilateral that is. If we really think about it, we've got congruent, 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 which would make it a kite. Now that's not that important to the situation that it's a kite, but what is important is that that is a quadrilateral, and you guys remember that a quadrilateral's angles have to add up to 360 degrees. Like the four angles in a rectangle add up to 360 degrees, four angles in a square, but it's any quadrilateral, the angles have to add up to 360 degrees. So we actually know three of the four angles. Now if we could find that central angle right here is going to be the same measure as the arc that it intercepts. So if we find that central angle, we'll therefore find the measure of W. So let's take 360 degrees, let's subtract off 90, let's subtract off 90 again, and let's subtract off that 54-degree angle. And when we do that math, we end up with 126 degrees. So that central angle is 126 degrees, which means that W is 126 degrees. Remember, what we talked about in 6.1 was that the central angle measure will be the same as the measure of its intercepted arc. So 126 degrees would be the answer for W. Looking at problem number 2, it says that line AB is tangent to both circles, and arc AMC is equal to 295 degrees. Find the measure of angle BQX. So we're looking for this angle right here, which would be BQX. So let's see, what do we know? Well, think back to the last problem. Again, tangent lines are going to be, this tangent line is going to be perpendicular to the radius drawn to the point of tangency. So we know that's 90 degrees. And on the other circle, we also know that's 90 degrees. That is one of our conjectures from today. Now, we also know that this entire arc, the major arc, AMC, so A to M to C, all of that is 295 degrees. Well, what is left over? 360 minus 295 leaves us with 65 degrees. So this arc right here between A and C is 65 degrees. But remember, that means that the central angle is also 65 degrees. Okay, so let's just do a little bit of an angle chase here. Notice we have a triangle. And we now know that we have a 65 degree angle, we have a 90 degree angle, and so now we just have to find the leftover angle right there. So 180 degrees in a triangle, minus 90, minus 65, that will leave us with 25 degrees. So this angle right here is 25 degrees. What's the angle directly across from that? Remember from our work first term, that's called a vertical angle. Vertical angles are congruent, so that is 25 degrees as well. And so that second smaller triangle will have the same exact measures as the first triangle. We've got a 90 degree angle, 25 degree angle. So that remaining angle, which is BQX, would have to be 65 degrees also. So the measure of angle BQX is 65 degrees.